Hello, hello, testing. Oh, so can everyone hear my voice? Okay. Can okay. So yeah, okay. Welcome everyone to our this first workshop before the first semester of the new year, new academic year. So yeah, my name is Chua Xiong Rong. I'm in the DSC Thai UC lead. Yeah, you can find me on this LinkedIn. Yeah. Okay. So today, yeah, correct. I need to open my camera first. Wait. Okay. Oh, hello. Hi. Okay, so today our workshop is about introduction to Docker and Kubernetes. So in this workshop, right, we'll be discussing about what is Docker and what is actually the container, and then the image, and also the difference between Docker and also virtual machine, and also details about Kubernetes, and also some demo about the Docker. The demo will be focusing on Docker and also the container, and lastly then we will have a bonus thing up. Okay, so without further ado, let's start our workshop. Okay, so why do we actually need Docker? So I give you in the slide here, right? We have actually got three tools, three language. So one is DB lah, and another is front end, and another is back end. So we have Node.js, MongoDB, and React.js. So imagine you want to develop application for these three of the tools, this stack. And yeah, the requirement is you need to use the MongoDB as a database, and the Node.js at the back end, and the React.js as the front end. So however, when you are actually building for this stack, right, you'll face a lot of issue while developing this application, because this is combination of different components, and there are some problem issue. Maybe they are having some issue in compatibility issues, such as the underlying OS. So like Windows and Linux, some tools or some technology cannot fully compatible to certain OS and also some library issues, such as the multiple components use the same use the same library, but they have the different version requirement. Like let's say Node.js require a library that version is higher than the React.js using a version that is lower. So you need to actually find a way to make all these works together. So you need to finding which of the version of the libraries or the dependency that you need to use in order to let all can able to compatible to your OS, to your library, to the tools. And then the problem with this, that this is called the hell from the metric from the hell. Metric from hell. If you don't know what is metric from the hell, you can try to Google search. So basically is very difficult for you to find a compatible. To find a suitable version for each different technology, because some might require higher version of the libraries. Some might require low version of the libraries. So here we have the Docker. So we use Docker to actually try to containerize all the technologies. So what it actually means that is, the first one is the compatibility dependency. Yeah, as I just now mentioned, you might have some compatibility issues, dependency issues due to the different requirement for each of the technology. So, and then each of the, if you try, if you're using the Docker, the container, right, you can solve this issue very easily, because each of the technology you can run inside different container that have different libraries and different dependency. And then I'm not sure you all got tried before. You have developed a project or assignment. Then after that, you are very excited to share it out to other people's, to like share to your friend lah. And but when you share the code or you share the file, the application to your friend, right? So when your friend are trying to use it, then you will face a lot of issue when he is trying to use your application, because some dependency, some libraries that he might don't have, but you have. So that's the problem. So we use Docker or we use containers to actually to solve this compatibility and dependency issues. And then the next one is the long setup times. So before we have this Docker or this container, right? We actually so in the current industry, right, we don't have just one environment. We actually have different environments. So such as we have the testing environment, we have the local environment, testing environment, and also production environment. So when you develop an application, so you want to let the different environment to be compatible, to be able to run. So you need to let the application run in locally and also run in test environment and also run in the production environment. But sometimes when legacy, I mean previous time, sometimes when you're able to run in locally, but when you try to bring your application to your testing environment, right? So you have faced a lot of issue due to because of the libraries and also the dependencies. So that's why we are using this Docker to make your application a container, so that every environment, such as a local testing or environment, can be able to share and also can use it. So this the theory, like you build one, you develop once, so you can run anywhere. And then like sometimes you also like let's say you are in the company, right? You have one new employee. So I joined the company. So he will have his own laptop or his own computer, right? So this process to set out his computer, to set out the local environment, is very take a lot of time, so it's very time consuming. So when you're using Docker, right, you can just give him an image or a container, so you can just directly use the container, because the dependency, the library, all inside the container. Then he can just simply run a run command, so you can use the container without setting all very troublesome libraries, installing a lot of things up. And then just now I said different development, testing, and production environment. So Docker can ease for the deployment of your applications, and also your, let's say, your libraries or your dependency, because each of a container consists of the application and also your dependency and also the library. Okay, so next. I think so already. Okay, so in general, what is the Docker? The Docker is actually a set of platform as a service product that use OS level visualizations to deliver the software in the package. So you can actually run each of your application in its own container. So the container, as you can see inside the this graph, right? So you have infrastructure. Infrastructure is mean your server or your laptop, your computer. And then we also have your the host operating system, like Linux, or you want to have like Windows, Mac OS, And then on top of the host operating system, then we will have the Docker. Docker is a container apps like this. So then on top of that, you can like containerize your application, like application A, application B, application C, yeah, until F. So each of the container like this, we actually call container. And then each of the container, it actually have their own dependency and also its own library. So when you try to use try to use the container, right, you won't like due to you won't have some many issues due to the library incompatibility or missing some libraries. Yeah, here I see here a lot of messages. Oh, okay. So I see many people answer already. Okay, so then the next one is okay. So maybe you all have heard about virtual machine container. Yeah. So what is actually the difference between the container and the virtual machine? So in this graph, right, we actually have the graph for Docker and also for the VM. So in VM, right, we actually have a physical server here at the bottom, and hypervisor is in case you don't know, hypervisor is actually a kind of emulator. It's help to create and run virtual machine. So the computer that use the hypervisor layer can actually run one or more virtual machine, which is called the host machine. The machine that run multiple virtual machine is called a host machine. The virtual machine is actually the guest machine. So as you can see right here, we have VM1, VM2, VM3. This three is actually the guest machine, and the physical server is actually the host machine. And if you see right, each of the VM inside you have your guest OS and binary and libraries, bins and libraries, and also your applications. So so each of the VM actually have their own independent OS. And then for Docker is actually in the at the bottom right is actually the physical server or VM, because you can actually run Docker inside VM, and the VM is inside a host machine. And okay, so the most bottom one is the physical server, or let's say your computer. And then the upper second layer will be the operating system. Your host OS either is Linux or your Windows. And then on top of the operating system, we have the Docker engine, which is help to manage the containers. And yeah, you can see that inside the container, we have our application, being the binaries and the libraries. Yeah, each of the is separate. Container 1, container 2, and container 3 is separated. So after this, I explain about the difference between the container and virtual machine, right? So what is each of the advantage or each of the advantage? So for virtual machine, right, in terms of utilization, because when you see this graph, right, you can see that we have when we see this graph, right, we actually have the guest OS, binary files, and apps. But in this Docker, right, we actually only have the application and also the binary and file. So in terms of utilization, right, for the for the UM, right, it does not it actually have a lot of overheads due to like loading different OS, because inside because inside each of the different OS, right, you have a lot of software that are pre-installed inside the guest OS, like startup manager or differentiation software. Yeah, you actually have a lot of application pre-built in the guest OS. So when you're running, right, so you actually have a lot of overhead. So it means that you need to take a lot of time. And when you're trying to use a VM, right, you will try to load the guest OS inside the memory first. So you will also increase more the overhead to your memory, more writing to install the OS to the memory. So you a lot of overload up. And then but with the Docker, right? Docker, if you see that we actually have the Docker, we only have the binaries and also the library and also the application. So we don't have the guest OS to be loaded into the memory. So this one Docker will be faster than the VM. So when you use, right, so Docker will be less. You're more like resource utilization lah. So VM will be a lot of things to load up. Okay, then the next one, in terms of size, right? Yeah, VM actually is much greater in size lah, because you have the Grace OS, you have a lot of the software, the application, the tools, the library that is pre-built inside the Guest OS. So the size is usually in GBs, few GBs, 2-3 GB like this lah. So this one is quite big. But for the Docker Docker it actually is the lightweight. So you will have only your application and also the binary file and also the library file that you require to run for your application. So in terms of the size, right? So in Docker image, right, you will be like MB size lah. MB size like maybe hundreds MB is actually also depends on your application lah. And then the third one will be boost up. Boost up, yeah, VM, because you're loading all the thing, all the guest OS, all the application. So in terms of boost out, right, the VM will take a lot of time. Usually maybe few minutes, 3 to 5 minutes like this to able to run your to boost out your VM. It actually also depends on your computer specification lah. But in Docker, it can boost up faster because it does not actually need to load the guest OS, because the OS they actually use is using your operating system, your host OS, your kernel. So you no need to load the guest OS inside the memory, then only to able to use the application to boost out. So in Docker compared with VM, right? So Docker will be faster, maybe usually about few seconds. So you can able to start your Docker container. And then for these two, right, they also got one difference is called isolations. So in Docker, right, Docker has actually lesser isolation, because when you see the graph, right, so you can actually see that the Docker in Docker, right, each of the container are actually sharing the same operating system, the host OS, the kernel. If let's say you're using the Linux, then the like Ubuntu, CentOS, or Kali Linux, right, all of these Linux distro, you will be using the Linux kernel. So in Docker, they are each of a container will be sharing the same kernel. But in VM, right, VM, because they actually have their own, because they actually have their own guest OS. So each of the VM will be using their own the guest OS, the kernel. So like maybe example the VM one is using the Linux. So you are using the Linux kernel. And VM2 is Windows, so you are using a Windows. So each of them have a better isolation in VM than the Docker. Okay, then the next one would be the portability. Container are easily to portable because they actually do not have separate operating system. So like let's say you are building the container 1, container 2, container 3 under the Linux kernel, right? So you can actually send this container or send the image, actually package into the image, send this image to the same Linux distro, like let's say Ubuntu, CentOS. They are actually highly compatible. But in VM, right, so it actually depends on the guest OS, like let's say the Windows or the Linux. So you cannot like sending the Windows file to the Linux file, or there will be a lot of process in order for you to run some the application which have the different OS or with different kernel. And then the next one, yeah. Okay, so yeah, okay, yeah. Next one. Okay, so just now we're talking about container and image, right? So what is actually the container and image? So in Docker image, it actually package or template that contain your applications, libraries, and tools, and also some dependency and other files that need to make your application works out. And so it's actually like same as the VM templates, like the image file. So, but the only difference is the Docker image don't have the guest OS thing lah. It's only have the libraries, the dependencies, and your application. But the VM got the guest, the OS thing, the stuff, all the application. Yeah, okay. So then the next one is the container. The container is actually running from it's actually the running instance of images that isolated and have their own environment and set of process lah. So you can actually create a container from the Docker image by running Docker run. Yeah, they can put your image, then you can create a container. Then each the Docker image you can run in many container, but each of the container is isolated, is isolated is different. Okay, so and then yeah. So if let's say one of your container is, let's say disruptor or destroy already, so due to like maybe some bugs or things lah. So one of your container is killed already lah, is died. So you can sorry. You can easily to create another container, like let's say you can create another container from the same Docker image. So you just run Docker run, then you'll be able to create a new container lah. Okay, so now we will be talking about what is actually this container orchestra. So imagine you have multiple, like this a Docker image. You have multiple container. Yeah, you have multiple container, and suddenly one die already. So you can simply create like one more container with the same image, right? Yeah, but this one is actually a bit troublesome, because like you need to have a person like go and monitor. Okay, this container died already, so I need to run another container with the same image. So but you try to imagine, if let's say you have hundreds or thousands of container. So you will be very hard for the person that you want to monitor the container. Then you will always, this die, you need to monitor each of the container. Is it die already, or is it the healthy of the container is die already. Yeah, it's very hard for the person to monitor each of the container. So here comes with the container orchestra. It's Orchestrate. Sorry. Yeah, another possible solution. Another possible problem is, let's say not your container destroyed, but it's your whole Docker. Your whole Docker due to some errors, then the whole Docker die already. So including, because if your Docker die, including all the container also die already. So imagine if your Docker die already. So then the person need to go against and run again to start again the Docker, and also start again all the container. Is actually very troublesome. Yeah, and then next another scenario is, if you, let's say just as I said, if you, let's say you have multiple, you have thousand, you have few thousand, 2,000 container running, and also a few Docker, different Docker, running. So it is very troublesome for the person that to manage this whole Docker things up. So you will be need to run, if let's say the one of the Docker die already, so you want to quite faster start a new Docker, run a new Docker, and then run again all the container inside the Docker. So this one is actually troublesome. So that's why we have this thing called container or Orchestrate. So what is actually container orchestration? Container orchestration is actually consists of tools and then the script that actually can help the host container in different environment. It actually help you to automate the deployment management, because when you have hundreds, you have many Docker and thousands of container, right? It's very hard to manage. So this container or Orchestrate help you to do the management of your Docker and also the management of your container. And it's also provide some scaling function and also networking for the container. This one I will discuss in the next slide. And then, yeah, you can actually also deploy the same application across the different environment without needing to redesign it. So the container orchestration. So this one, the deploy the same application, it means that you have in container orchestration, they actually have a host machine, the master node and also the other nodes. So the master node will be controlling all the other nodes that like wish to deploy the new Docker, and also the master node will help to do all the scheduling and also networking. Yeah, in this slide is, so why we using the container or orchestrate? So yeah, the first one deploy, because when you are using the container, right, so you want to ease your your deployment of your application to different environment. So you can actually by using the container orchestrate, right, you can actually very easily to deploy your container to any worker nodes through the master nodes. You can like do scheduling, And then next is the configuring and scaling of container. The container orchestration help you to configure each of the container, each of your container or each of the nodes, each of the workers node, and also scheduling the container. What is mean by scheduling of containers? Is like, let's say in night time, right? So usually people are not active, so the access to, let's say you have a web application, the access to the networking loads for your application is not very high in night, right? So you can try to reduce some container, try to reduce some worker nodes. So you can actually don't overuse your resources. And then if let's say you have sometime a container die already because the bug or because some bug or because other issue, so a container die. So in this container occasion, he can faster go and schedule a new container to replace the container. So you can have to schedule a new container to help to replace the container in order to make sure the application can continue to provide the service. And then next one will be the network. The network, is also help to provide some load balancing, traffic routing, and service discovery of container. So for what is actually the service discovery of container, as I just mentioned, right? Sorry. So if you see this image, right, each of the container, they are actually isolated. They are actually have each different has its own different part. So in this container orchestra, right, it can actually help to help to do some service discovery. So each of the container have its own service. Service that available in the container. So container orchestrate can actually help you to find out which service are currently running in which container without you actually go and try to write some script to get the IP address of each of the container and then try to check what service actually running in this container and then what service actually running in another container. So container orchestra help you to do all these things. So it will reduce your workload. And then the next one is a health monitoring of container. Yeah, just like as I mentioned, if let's say one of your container die already, so so you can replace, right? So but this container orchestra, you will before the container die, you will try to monitor the health of the container. Is it like the networking? Is it suddenly spike very high, or is it have some, how to say, some issue already starting to have some issue Yeah, so this container help you to container orchestra help you to do the monitoring of each of container, so you can actually know, okay, which container is going to die, or which container is now like very free, nothing to do. Yeah. And then the next is the security and securing the interaction between the container. Yeah. So because each of the container is isolated, so you have to securing the interaction between container. Like let's say if sometimes each of the container have a same application. Like let's say you do a container A, example. Maybe find some. Maybe I try this answer. So maybe you maybe you have 2 or 3 container is actually running the same application. The same application, like maybe you are writing a Python code, web service. Let's say like Shopee you have multiple container is running the same application, same code, and then they are inside, they have same have same service. Let's say they both using the same back-end services. So the user, so the security so the container or orchestrate, right, can actually help how to manage, like you will try to get all the same service from each of the container, right? So you when user accessing your web, your Shopee, so you can, like let's say the first container, the backend is down already, so you can faster direct the connection to another container with the same backend. It's the same application. And then also you also make sure the availability of the container. So there are actually some few very popular container orchestration tools, like the Kubernetes. Kubernetes is the most popular one. So we also have the Docker Swarm, and we also have the Meso. These are different container orchestration tools. And also the Kubernetes actually allow you to use different container. So because for this visualization technology, right, we don't just have the Docker, this Docker container technology, but we also have other container technology like the Rocket and other else. So this one is actually the architecture of the Kubernetes. So as you can see that we have this Kubernetes master node. So master nodes will be they will have a scheduler and also control manager that will be help to manage each of the working nodes. each of working node. So when user and trying to access the Kubernetes proxy, right? So the user will be trying to use the Kubernetes to access for the each of the working nodes to access the web application or and the Kubernetes master node will be how to manage each of the working nodes and make sure that if let's say the container die in the working nodes, so you have schedule another new container for this working nodes. Okay. Yeah. Okay. So now theory time is finished. So we are going to the demo. In this demo, I will be demonstrating some very how to deploy your Node.js application, a very simple Node.js web application to Docker. Create your image and then run your container. And then also we'll be guiding on how to do the installation of the Docker and then how to switch your container your Linux container or Windows kernel. Okay, so wait, I now change my screen first. Yeah, so everyone can see my screen. Okay. Yes. Okay. So now, so for you to download the Docker, right, you can go and try this Docker, and you just type it out. Then there's a new thing. Yeah, you can go get started. You can choose to download the Docker desktop. You can based on your operating system, you can download for Windows or Mac or your Apple, or you can view the Linux engine. So after you download it, you can go and install your application. So, but I already installed, so I will just show you this. So this is my Docker lah. So before after you install the Docker already, right? If you are running Windows, so you will actually have a Windows backend. But if you let's say you want to try to change to the Linux kernel, you want to run some Linux kernel, right? So you can actually go here. You have one switch to Windows kernel. But now I currently is in the Linux backend. So this one will be switch to Windows container. But you can easily switch between Windows backend or you want to switch to the Linux backend lah. So why we actually want to switch to different window window backend or Linux backend, because some of the container that require you to run on the Linux kernel and some the container that might need you to run in window kernel or window backend lah. And then something to take note that some of the maybe you guys are using like virtual machine, VirtualBox, VMware, this kind of thing, right? You need to do like feature window turning your window features on. You need to you can just click the Hyper-V, and I'm not sure which to enable already, but you just enable all the visualization tools, then should be okay already. So like Hyper-V, and then you also have wait, let me find it. Like the Window Hyper-V platform. So after you enable already, right? So you only can use VirtualBox and also the Docker together, because when you didn't enable these few things, right, when you try to run VMware, then it will prompt you a message you cannot run due to some Hyper-V problem, Hyper-V problem. So in order to solve this issue, you need to turn on the few features that I tell you just now. Okay, so these are some things to take notes. And then yeah, also like setting, you also can try to play around, because in my Windows operating system, right, I actually installed the Windows subsystem Linux 2 based engine. So if you didn't have this Windows subsystem Linux 2 engine, right, so it won't allow you to run the Linux backend. So if you want to run some Linux container, right, so you need to install the WSL first, then you try to enable it. Yeah, here also got mentioned that you need to no, sorry, this one is wrong. So you need to install your WSL first and install one of the Ubuntu, one of the Linux distro. Like I have actually the Ubuntu 20.04 LTSR. This one is actually my Linux kernel. Okay, then you can try to play around the setting here. Yeah, as long as you didn't make it not make it hold down or die lah. Okay, so yeah, now we will be going to try to build a image Node.js web application, a very basic, a simple Node.js web application. Web application, and then we build the image, then we try to run the container. So yeah, yeah. Before that, I also can tell you this is a running container that I have, and these are all the image that I have. The currently I have installed. To if you let's say you want to try to find image you can actually go to the Docker Hub. So inside this Docker Hub, right, you can search a lot of images. Like let's say you want to like MariaDB. Yeah, you can simply just copy this command and you go to the CMD and then just paste it. You paste it, then you will start to load. Try to pull the image down. So yeah, I think it will take some time. So this one is actually downloading the image and then extracting the file. Okay, so now the MariaDB already finished downloaded. Yeah, you can see that. Yeah, I have already one more the image on the disk. So this is the MariaDB. So the tag which the version of the image. So this I choose the latest. This one don't really care. I also not sure why the 8 hours ago. And yeah, the size is about 407 MB. Okay. Yeah, you can actually still have a lot of other images you can find here official, or if Ubuntu, Redis, Node.js. Yeah, these were image that I will be using during the later the demo. Yeah, there are also a lot of the image you can find. Yeah, for you guys, like if you, because some of the assignment maybe you face later or what some of the requirement is you need to use some some other database and also some other tools like some other technology. But one trick is, if you, let's say you don't want to install, like let's say you don't want to install MySQL inside your computer, you find that it's very troublesome. You need to install this, install that. Then after you use finish, then you need to uninstall it. Then also a long process, right? And also like have a lot of the residual file left inside your computer. So you can actually try to use Docker. You try to put the image and then you run a container, then you access the MySQL through your MS through your the Azure Data Studio or like other database management tool SQL database manage. Yeah, go on SQL management, SQL database management, you can easily try to use the MySQL without actually go and install the MySQL inside your computer. So got people ask that Docker can run various language without needing to install different software. Yeah, you can. The language you mean is actually programming language. So if you means like programming language and also the tools, right? So yeah, you can because each of a container is isolated. The only things they sharing is the kernel. So you can, like, let's say you have container one is running Node.js. You have container two is running MySQL or other database thing lah. So and you can container three running other things lah. As long as this all these container they need to have the same Linux and the Linux kernel or Windows kernel, that kind of things, because they are sharing the kernel. Yeah. You can run many different language. You can run Python, you can run Node.js, you can run React.js, or you can run each of the language inside the container, and then they are all isolated. Yeah, of course, if let's say you want to access the database, yeah, you can actually can actually have Node.js backend service container accessing another container that is the, like, let's say MySQL for the database. You can actually do like this. Yeah, okay. Do I answer your question? I think okay. Yeah. You can actually go through all these, the Docker how, and read all these. Yeah, how to run it, how to use the image. Yeah. Okay. So and then where I am now. Okay. So these are all the images. So the volume is actually this one. The volume. I think because just now I run MySQL, so your volume. Yeah, this one dev environment. Yeah, no need lah. I think haven't started. Yeah. So I need to run different language in different container. Different language. You can run different language in different container, or you can run same language in different container. Also okay. No problem. You can multiple Python project. Container one is Python project. Container two is Python project. Container three is Python project. It's okay. No problem. No problem. Yeah. Okay. So yeah. Now is the demo time for building our first Node.js application. Okay. So this is my Visual Studio lah. So first of all, I open a file. First, I open folder. Maybe desktop. I create a new folder that's called my apps lah. Okay. So I go this my apps. I select my folder. Yeah, this one Visual Studio is a very popular software, and to write your codes, to run many things. Okay. Yeah. Okay. So now I will be doing the initialization of create the first version of the Node.js. But yeah. Okay. npm. Okay. Wait, a bit slow. Yeah, okay. So after I run, I'm not sure you guys are familiar with Node.js, familiar with npm or not lah. But in this demo, right, the Node.js is actually not the important part. So I just write some very simple code to build a very simple web application. Okay, so this okay, I have a package JSON. Yeah, this one is actually the configuration for my web application. And yeah, in this demo, right, I will be using the Express.js. You can try to search what is Express.js. Express.js is actually very simple things, the framework for you to build a web application. So yeah, okay, so I will be npm install Express. So now I will be installing all the Node module, the Express module inside my apps folder. So you can see the Node module, you have a lot of things inside here. And we have a package log and also package.json. Okay, now our main is the index.js, so we try to create the like the main door lah, the main door to your application. So I try to create a index.js file type index. You can ignore the this error lah. Actually, the things that I want to do is actually create a file. Then you can see that my new file index.js. It actually same comments like the touch in the Linux. So if you guys are familiar with Linux, it actually touch comment, but I actually more familiar to touch. Incidentally, I'm not sure why they want to put type. It'll be weird. So in this index.js, so I will be writing our first Node.js backend. So yeah, you guys can not actually understand also okay lah, but because this is not the important part here. So use strict is actually you can try to Google search what is JavaScript use strict. So it's actually not allow you to use any variable that is undeclared. And then okay, so I try to do the load the express. So require express. Then try to write our port. Our port for this application in the container. So it means that when we want try to access to this web application, right? So we need to go through this port. Let's say example 8080. So and then the host. Say host 0.0.0.0. Host I put, then I try to initialize the application daemon. Oh, no. What is that? What is that? Okay, so constant apps express. Try to initialize the express. So I try to escape. Oh, no, oh, you mean the photo reflection? Oh, okay. Oh, wow. Wow, really? Hey, I'm not sure because I use this Node.js. I also not very familiar, but this time because I was just building a very simple application. So maybe I can explain a bit about this. What is do So you actually try to just write the like request and respond. After request, then you try to write some HTML to, as a response to the front end. I'm also not very familiar too. Maybe our future event we will be doing some workshop about Node.js. Yeah. Welcome to intro to Docker and Kubernetes. Okay. Yeah. So then we do the apps listen to the port and so the host. And maybe try to write some console log running on. Hey, sorry. Okay, so this the very basic Node.js. So you actually try print this thing out. Hey, yeah, I think got an error. Oh, no error. Okay, so after this is actually a very simple web application. Then maybe you can try npm index.js. Sorry, not npm. Wait, so after I'm running the dot in index.js, JS, right, you can actually see, okay, so we have point to our localhost to 0.08080, right? So you will show, oh, hello world, welcome to intro to Docker and Kubernetes. Yeah, this means that our application is successful already. So it's very simple web apps only. So yeah, we just stop it. And okay, now we are going to write our Docker file. So okay, let me open the new file. Docker file. So what is this Docker file? It actually means the Docker file is for you to write some like configuration things, or for later you want to build your image, you can use this Docker file. Then you build an image. Then you can use this image and do to run all the container. Okay, so in this Docker file, you can, okay, so Docker file is the main thing. Yeah, okay, so this from command is actually from base image. You can see it already explained it very well. So from you want to from which base image, so you will be you will try to download the base image. Then you will run this code, deploy this application. You are that is my apps into this Node.js, the base image, and then create another image which containing your Node.js application and also the Node.js. So this time we will be using the Node 12. The version is Node 12. Yeah. Then you can write work dir. Yeah, work dir is mean like working directory in the container. The working directory for the container inside, because in each of container, right, it actually has their own structure, has its file structure. So let's say I want to install at the user src. I want to install at this location. So I work dir here, and then I try to copy all the package, everything JSON to here, and then I run npm install. This is the standard procedure. So I copy the package to the container first, to the container. Then I try to run the npm install. Then after run npm install, I copy our index.js file to the container. Yeah, I just actually copy everything here. Sorry. And then we try to expose. Expose means that you want to export your post. Port means you allow the port to be open and allow the other connection to be connected through the port. Yeah. So I try to A080. And then yeah, command to be execute. So you can running nodes index.js. So this one is the command that we will be running after we have npm install, copy the index file to the container. So before running this cmd, right, the container, the file structure will be similar like this my app's file structure. So we have a Node.js, the Docker file, the image JS package, and all the package JSON. All these are a bit similar. And then okay, so this one is our Docker file. Then just save it. Already done. And then yeah, if let's say you want to try to do, I'm not sure you guys actually know about git ignore. Git ignore is actually you want to ignore some file from copying to the repository. So it's like similar, like we actually also have something called a Docker ignore. Yeah, is it Docker ignore? No, sorry, rename. Yeah, need to. Yeah, Docker ignore. We also have a Docker ignore, so it actually similar like the git ignore function lah. So you just ignore some specific file that you don't want to deploy to the, or you don't want to copy to the container, or don't want to copy to the repository. So in this, actually no need lah. I just demo about ignore. And then okay, so now we're going to build our image. So you want to build the image, you can try to Docker build pp is a tag. Then maybe I'll try to do my apps. So our version is 0.00. Then so now you are trying to load all the Docker file, and because I actually have the node image with the version is 12 already installed in my image. So if you see here where image, yeah, it actually is this non image, but yeah, because I didn't specify the image name for the image, so when download you will just become a none. But this one is actually the Node.js, the image file. So okay, so we have done everything right. So now we'll be, if you can also write some commands like you want to see all the see all the image. You can write like this. Then you will see my apps, all these image. You can use either the CLI or you want to use the UI version of the Docker. And then okay, now we try to run a container from the image that we built just now. So we Docker run, so P will specific for the port. So in this case, right, we tried this one, the first 8080 is the port that we want to open in our host machine. And then this 8080 behind is the port that open at the container. So you are like you are doing a connection between your host machine with the container. So when you try to access, try to use the port 8080, right, the machine will be know, or you want to try to point to this to the 800 port of the container. And then later you need to specify the image that you want to use. So this in this case is my apps. Tag is 1010. So we need to wait a while. Okay, so you're showing the running on here, right? So we can actually try to, oh shit. Oh my god. Okay, so just again. Okay. So because here I already start the image, the container, right? You can see that you can see my apps point, the tag my apps already running. This is a container that we are running now. And you can accept is you can just try to run this one, try to 8080. And congratulations, you are just done deploy your application to the container. So you can see hello world, welcome to intro Docker and Kubernetes. So if then you because you build the image already, then you have you will see that your image is already in your disk. So if let's say you want to share it to other people, so you can actually push to hub log. You can push my apps to the hub, so for people to download and use it. If you think you want to share it, and then you can actually inspect. And these the commands are running. You can also inspect for the things like node version, because this is the base image still is the node image. So the node version and also the binding and also the state. The state is this container is using how many of your these read write, your memory usage. You can have inside of the container help. In this UI, I can easily see only 10 MB memory usage. 10 MB I mean the application 10 MB Okay, but because Node.js itself is quite big. If you know, right? So itself, you see my apps. I only just write a very simple web application. You need to take about 1 GB. I run my Discord bot with Node.js in my computer 1 GB RAM. Wow. Yeah, Node.js it really eat a lot of things. It eat a lot of resources. And then yeah, okay. So then the next I trying to let you guys see about you can actually view the structure of the file. Like let's say I want to try I'll try Docker. I execute. Execute is actually you want to execute some command in the Docker. So as I just said, each of the container is also have its own file structure hierarchy. Okay, let's say I want to try sql.it. So I try. Wait, where is my image name? My image name is cookie Cohen. So I try to get a batch. So you can see that I'm now actually inside the command line, the bash of the container. If I run ls, yeah, you can see. So you can actually see all the file JSON inside my apps, right, is already deployed in the container. You can see everything inside here. Yeah, as I just said, because this one I was using the Linux backend. So sorry, it goes like Discord. Yeah, oh shit. So you can see that my file everything inside, because I when you build your application, then you need to copy all the file inside the container. Then you can run it. So yeah, okay, and then you also can do. Okay, after I finish it, I just exit lah. So you can exit back to my to my CMD, and then you can do like let's say Docker PS. Docker PS is actually see what container are currently running lah. So as you can see that my apps is running and my SQL is running. So status, you can see the status here 2 minutes ago. This one is 2 hours ago, and then the binding of the port, yeah, and then the map. So if let's say you want to try to close, you want to queue you want to stop the container, right? You can simply just Docker, and then you stop. You can use you actually have two options. You can use the first 4 digit of the Docker ID, or you can just use the name of the container. Okay, sorry, the first 4 digit of the container ID. Let's say I try to do S242F40. I try to solve it. Oh, wait, yeah, okay. Now I have successfully closed the stop the container, so you can see my container is now is at the exit status so it means it's stopped already. So my SQL also can you can stop it. Yeah, this is the demo of the basic of the using how to use the Docker to build your use Docker to run your own Node.js web application container. Yeah, okay. So that's all for the demo. So let's come back to the. Where is my presentation? Not this one. Okay. So yeah, the next. Okay. So our demo is already finished. So yeah. Now we have the bonus you guys can actually redeem for your GDSC TiUC member. This is actually a batch. After you try to click it right here, maybe I'll share the code. Okay, cancel it. Yeah. Okay, yeah. Oh wow, so fast. Anyway, yeah, ask something. May I ask if the application code is performed using other software like PyCharm? Okay, I know, is it the same way to create a JSON file and Docker file? The JSON file, I think you means is it's a Node.js file, right? Actually different. So PyCharm have its own, its own configuration things one, but not necessary to be JSON file. JSON file is for just now .js. They have one JSON file is for the Node.js configuration file. So for PyCharm, this one I'm not sure, but you can, like, let's say you run PyCharm and maybe build some application in Python, and then you can try to perform a similar. Wait, just now the Docker. The Docker file. Yeah. No, but basically it's just you need to specify the working directory, and then you copy the file to the container, and then maybe you want to run some Python if you, let's say you are using the Django, right, you can python.run server. Yeah, but this one you need to actually go and check for the documentation of the image. I think, wait, Docker. Yeah, I think, I'm not sure, is it already have a PyCharm? Yeah, I think you actually have the image file already. You can try to download this image, pull this image down, and maybe write some code, and then you use this PyCharm as a base image file, and then you put all your file inside this file drive and run it up. But for more details, you need to go through all the documentation in here. No, not this. Yeah, you need to go through the documentation. Oh, PyCharm is IDE, yeah, but the file that you want to run, or you want to run the PyCharm in the container. Yeah, I think should be able to do it. If let's say you want to run some file, like you want to use the Django. Django is the web application framework for the Python. Yeah, you can just do like me, or you want to use a PyCharm, like PyCharm, maybe I'm not very sure about this. You need to find the documentation. But if you want to do some very basic web application deployment, then you can do like Node.js. Just now the example is Node.js. You can do like similar like me. So you have the base image first, then you copy all your code to the image, and then build your own image and run the container. Okay, so any question? Ooh, yeah, finally finished already. Okay, any questions? So if no question, then I think we can end the session now. Yeah, remember to go and redeem your badges lah. Here, yeah, a bit late already, you know. 9:45 already. How is it? And you can redeem the badge, and then maybe you want to share it out to your LinkedIn, or you want to share it out to your social media. You remember to tag us, tag Developer Student Club, and tag TaiUC Developer Student Club. Yeah. Wow, thank you. Wow. Wow, thank you. Hey, first time nih. Next time need to belanja makan tea, yum cha already. So anyone has any question? So if no question, then I think we can stop now. Yeah, okay. No question. So thank you everyone. So our workshop is end already lah. Okay, thank you. And then later we'll be sharing all this slide and also the image that I've created, the image I've created, and also the recording for you guys lah. Later lah, we'll be posting on the social media. So be sure to stay tuned for our social media for the recording and all the resources follow. Okay, thank you everyone. Thank you. I hope this one can help you guys in assignment. Yeah, maybe when you are doing you want to use some very special technology, you can try to use this Docker technology because I'm the bachelor degree in software engineering. So one of the course is require you to use some very special database like last time I used Cassandra. So if let's say you don't want to download and install the Cassandra in your laptop or your PC, right? So you can just directly pull the Cassandra image and run it in container. Then after finish, you can just delete it. Yeah. is very senang. Okay, very easy for you to do. You have to do some very fancy things. Yeah, you have to isolated from your host machine. Can go help me for this. Okay, thank you everyone. Thank you. Bye bye.